Hello everyone, and welcome to episode 2 of our NF Core webinar, a brief review of Nextflow. In the last episode, we discussed why you would want to apply the NF Core framework to your Nextflow pipelines while you're in development, because it brings things like reproducibility, portability, and scalability, as well as a robust community to the table. Now, as I said at the beginning of this webinar series, I really recommend that you have a basic understanding of Nextflow pipelines and how they are constructed before going through this webinar series. However, this episode will cover the basics of Nextflow that you will need to understand the next two episodes, where we will run and then design a simple NF Core pipeline. And to help conceptualize this episode, I want you to consider the metaphor of Lego bricks and builds, in which workflows are the completed build, processes are the actual block pieces composing the completed build, and channels are the studs that protrude from the brick to connect each piece. And by the end of this episode, you should be able to define what a channel is and explain the difference between queue channels and value channels. You should be able to define what a process is and explain the three main parts of a process. And you should be able to define what a workflow is and explain how processes and channels together make workflows. So starting off with channels. From a high level perspective, channels are used as a way to transfer data from one step to the next. Channels can store items such as files. For example, in many bioinformatic workflows, that would be something like FASTQ files, or they can store values such as the number of reads in a FASTQ file. Nextflow distinguishes between two different kinds of channels, though, which are queue channels and value channels. Queue channels connect a producer process, a process that outputs a value, to a consumer process, a process that takes in a value. It also can connect to an operator. A queue channel is consumed and can only be used once. Queue channels can be created using the following methods, which are also known as channel factories. And I'm going to type these out. I'm going to go ahead and just open a new document. I have my terminal in Visual Studio Code open here, and I'm just going to open a text file and type these out so you can see what they are. Let me minimize my terminal here. So the first channel factory, or the method by which you can create a queue channel, is channel of, CHANNEL .of, and then an open parentheses and a closed parentheses. And channel of creates a channel that emits the arguments that are provided to it. The next one is channel.fromList. And the L in list should be capitalized. And we're going to do an open and closed parentheses again, because all of these methods require an open and closed parentheses at the end. Channel from path. And path should be capitalized in that. And this creates a channel emitting one or more file paths, so you would give it the path to a directory with files within it. And then we have channel from file pairs. Now this is a very common one at the beginning of bioinformatic workflows, because it creates a channel emitting the pairs matching a glob pattern. And so often this will be FASTQ files. I'll show you an example of what this looks like in a second. And then the next is channel.from SRA. So SRA referring to the archive in the NCBI database. And this queries the NCBI SRA database and returns a channel emitting the FASTQ files matching a project or a session number. And so these are the different ways you can make a queue channel, and I'm going to show you a few examples of these. So I'm going to go ahead and just close this here, and I do not want to save. And I'm going to open a new document, and this document is going to be just a simple Nextflow script that we are going to run. So we're going to open a new text file. If you're using Nano or Vim as a text editor, go ahead and open your document that way as you type along with me. But first, we're just going to give a simple example of channel.of. And so if we're making a channel via channel.of, let's call this, we're going to make a channel that's a list of strings. And so we're going to go ahead and call this species underscore ch, so species channel, and I'm going to set that equal to channel dot of, and that's going to be an open and closed parenthesis. And within that open and closed parenthesis, I'm going to put a few strings. Since I am a bacteriologist by training, I'm going to put bacteria names here. So we'll put E. coli as one, and then we're going to put a comma, put another pair of single quotes. Next, we're going to go with K. pneumoniae for Klebsiella pneumoniae. And then after that, I'm going to put M. morganii for Morganella morganii. And you can put any list of strings here. This is just what I'm choosing for mine. Morganii. And so I have set the species channel to channel.of, and then I'm going to use the view operator so that when I run this Nextflow script, it will print what's within this channel. And so we're going to do species underscore ch dot view. And then we're going to save this as species dot nf. So let's go ahead and open back up the terminal. And you can see here in my little folder here, my file explorer, that we now have this script here called species.nf. And if I were to do ls, oh, it looks like I saved that within the outbreak folder. Let's see. Yep. No. Oh, it got saved all the way in FASTQ data. Not sure how that happened. I might have accidentally had that selected, but that is okay. I can very easily move that to my current directory. So let's move from the outbreak folder to the FASTQ data folder to species.nf, and we're going to move it here. And as you can see, this is now in my present directory. I like to have my terminal clear, so I'm going to clear my terminal. And now we have species.nf here in this directory. Now, if I want to run species.nf, I need to use the nextflow command. And then I'm going to say nextflow species.nf, and I'm going to hit enter to run the script. Nextflow starts running, and it prints each string in that channel, starting with E. coli, followed by K. pneumoniae, and then M. morganii. Let's go ahead and close this since it's moved, and we'll reopen it. And you can see here in the File Explorer that we have the working directory that comes up when Nextflow runs, as well as the first nextflow.log file. So you'll see these files pop up in the File Explorer as we run Nextflow scripts. Let's go ahead and change this to E. cloacae. And we'll hit save, and then we'll run it again. And this time it printed out E. cloacae instead of M. morganii. So that is how you use something like the channel of. And now we're going to go ahead and do channel from path, because that's another common way to bring in multiple files into a channel. And so getting a little ahead of myself here, we have this outbreak folder. And this outbreak folder, if we do tree and then outbreak, it will print the file structure. We have the directory outbreak, followed by the directory FASTQ data, and then we have these FASTQ, these gzipped FASTQ files here. So we have the read 1 and 2 for sample 1, read 1 and 2 for sample 2, and read 1 and 2 for sample 3. So I want to take in all of these FASTQ files from this FASTQ data directory and put them into a channel. So let's close species.nf. And we're going to open a new text file. You can create a queue channel with multiple files matching a specific pattern using glob syntax. And I mentioned glob earlier. For those of you who don't know, there are multiple characters used in glob syntax, but for our example, we're just going to use the asterisk. If you go to the webinar materials for this webinar, there's actually a link where you can read more about glob pattern matching, or you can do a Google search and find lots of information out there and guides on how to use glob pattern matching if you want to bring in files from a matching a particular syntax. So this time we are going to make a channel called reads_ch. Let me again move my terminal out of the way so it's not cluttering things. Reads_ch. And we're going to set this equal to channel.fromPath. I almost typed of there by default because I was on autopilot, but now that we have the from path option here, we're going to put in single quotes the path, and in this case it will be outbreak /fastq_data, and then another / and then an asterisk and the extension of our files. So in this case, our file extension is .fastq.gz. So we're using the asterisk to indicate that we want to get every file that ends with .fastq.gz in this particular directory. So then we need to type .fastq.gz. And again, because when I run the script, I want to see what's in the channel, I'm going to do reads_ch.view to view what's in the channel when I run the script. So we're going to go ahead and save as. We're going to call this reads.nf. And now we'll bring the terminal back up. If we do ls, we can see reads.nf is now here in our path, and we're going to run it using Nextflow reads.nf. Nextflow runs and it prints the path to every file in the fastq data directory within the outbreak directory that ends with .fastq.gz. And that is how you would bring in files matching a particular extension and put them into a channel. The final example I'm going to show you for making a Q channel is a very common one, because it's used to bring in fastq files similar to this, and that is channel.fromFilePairs, which I previously mentioned. So let's close this, and we're going to open a new file again. Move terminal down so it's out of the way. So we're going to make another reads_ch channel, but this time we're going to call it paired reads_ch. And we're going to put channel.fromFilePairs. And fromFilePairs takes in a path just like channel.fromPath does, but you need to specify what the pair is in this case that you're going to read into the channel. So again, the path to these fastq files is outbreak and then fastq_data. And then we have another /, and this time what we do is we need to put an asterisk followed by an underscore, and then we need to add some curly brackets, because instead of giving the channel each individual file, we're going to give it to it in pairs because we have paired in data. We have read 1 and read 2. So within these curly brackets, we're going to do R1, comma, R2. And if these were _1 and _2 fastq files, you would do something like 1 and 2. But we have a read 1 and read 2 that's specified by R1 and 2, so we're going to type in _R1, R2. And then we're going to put .fastq.gz. And this tells Nextflow that we want to read in the paired fastq files into this channel called paired reads_ch. And when we do that, this time we're once again going to use paired reads_ch.view. And then we're going to do save. And we're going to call this, what do we want to call this one? Paired reads.nf. We're going to save that, bring the terminal back up, and we're going to run Nextflow. So Nextflow paired reads.nf, and we're going to click enter. And notice this time the structure is different. When we used channel from path, each FASTQ file in the path is one item in this channel, but this time it's paired, where we have the sample name, so in this case sample 1, 2, and 3, the path to the first read, read 1, and the path to the second read, read 2, and they're stored this way. So this is incredibly useful for when you're running a bioinformatic workflow with paired in data, to bring in your FASTQ files into a channel in this format, because you have both the sample name, the first read, and then the second read as a tuple. So we've covered Q channels, and now the other type of channel we need to discuss are value channels. Let's go ahead and close this file, move the terminal back up, and then we're going to clear the terminal again, just so it's a little less chaotic. And value channels consist of a single value, which can be consumed multiple times by a process or operator. So we're going to make a channel in a new file, and we're going to call this microbe_ch. And we're going to set this equal to channel.value with a closed parenthesis and an open parenthesis. And we're going to call this bacteria. And that is going to be the value we give to our channel. And then we're going to do microbe_ch.view, so that when we run the script, it will print what's in the channel. And we're going to save this as microbe.nf. Now, when we do ls, we see that microbe.nf is now in our path, and we're going to run it with Nextflow. So Nextflow microbe.nf. And there it prints out the value in the channel, which is bacteria. Now it's important to note that a list of multiple values counts as a single item and can be assigned to a value channel. So we're going to go back to microbe.nf, and to save a little time rather than making a whole new file, what we're going to do is we're going to start by making a list of values within this value channel. And to do that, we need to use an open bracket and a closed bracket. So we have bacteria, and then we're going to add a comma, and we're going to add viruses, and then we're going to add yeast. So these are different types of microbes. And we're going to add microbes, so we're going to make it plural. And then we're going to save this as a new file name called microbes.nf. And if we do ls, we see that microbes.nf is now in our path, and we're going to run it with Nextflow. And when we run microbes.nf, we get the output bacteria, viruses, and yeast. We get that list. So that list can be stored in a value channel, even though it contains multiple items, because that list counts as a single item. So now that we've discussed Q and value channels, I have one challenge for you before we move on to discussing processes. And this challenge is, how would you create a Q channel named FASTA_CH with files with the FASTA extension found in a directory named data/FASTA_files? And let's just open a file so that you have this information. So we want a channel named FASTA_CH. We want it to take in files that end in the .fasta extension, and we want the path to be data/FASTA files /. So go ahead and take a few moments to do this challenge. You can hit pause, do the challenge, and then I'll give you the answer, or you can just skip straight to the answer. So the answer to this challenge: to make a channel of FASTA files with the FASTA extension from the path data/FASTA_files. You would make your channel FASTA_ch. You would set it equal to channel.fromPath, and then you would, within from path, put in single quotes data/FASTA_files, and then another / and the extension .FASTA. And this would give you every FASTA file in this path. It would store it in a channel named FASTA_ch. So now that we've discussed queue and value channels, we can move on to discussing processes. And processes are the individual actions that make up a workflow. Nextflow uses processes to execute commands or scripts the same way you would run a command on the command line. Processes are independent of each other, and data is passed between them via input and output channels. These channels allow Nextflow to coordinate the execution of each step in a workflow. So I have a figure to show you that I've made. I have it pulled up in the Chrome browser here. You can actually find it in the webinar materials in the GitHub repository. But this figure below visually represents how channels pass data to processes. So we have our input here, which is file 1. File 1 goes into a channel called channel A, and then that is given to process X, which executes a task. The output of process X is in a channel called channel B, which is then given to process Y, which executes a task, and the output of process Y is in a channel called channel C. Now next we're going to talk about the anatomy of a process. So we're going to go back to our terminal. And in this section, we're going to discuss the three components of a process: the script, input, and output blocks. A process is made up of the process function, a name, and a body. And the name of the process describes what that process is doing, while the body, which is contained within curly brackets, consists of the command or script that the process executes. So I am going to, minimize this to decrease clutter, and I'm going to open a new text file, moving the terminal down. And we're going to start by just writing a simple process called hello. So a process is defined with the word process, followed by the name of that process, which in this case is hello, and then an open curly bracket, and we're going to press enter so that we have our closed curly bracket here at the bottom. And then you have something called the script block, which we're going to talk more about in a second. You type a colon, and then you press enter, and then you need to have 3 single quotes, which defines the script block. And we're going to hit enter again and type in another 3 quotes, which closes the script block. And within the script block itself, we're going to write what the process does. And in this process, we're going to write echo, and then in quotes, hello world, with an exclamation mark. So remember, if I were to type in echo hello world on the command line and run it, it would print the statement hello world. But in this case, we're defining this within a process so that the Nextflow script we run will echo it. And it's important to note that this hello process does not need an input or output block that I previously mentioned, because it returns text, and that's just a special rule within Nextflow. So we're going to close this and open a new file, because next we're going to talk about the script block. I just showed you how you write and define a script block within a process, but I'm going to give you more information about what the script block is. The script block defines the script or command executed by the process, and a process must define a script or something called an exec section. We're not going to review what an exec section is in this episode because it's outside of the scope of this webinar series, but you can read more about them in Nextflow's documentation. If you go to the webinar materials GitHub repo for this webinar, you can find a link to it there. And then All other sections in a process are optional. So in the hello process that we just did, the script section was defined using the word script. And now I'm going to show you another example of a script block. So you define a process by typing the word process, you put a space, and then you type the name of the process. So the name of our process that we're going to do next is called count sequences. And this name is very self-explanatory. This process that we're writing is going to count the number of sequences in a FASTA file. So we've given the process a name, and now we need to give it an open and closed curly bracket. And then we're going to type the word script, followed by a colon, and then we need to define the script block with double quotes. And it's 3 double quotes, followed by another 3 double quotes, and that defines the script block after we have typed the word script. The particular command we're going to use to get the number of sequences in the FASTA file is called grep. You might be familiar with grep. It looks for patterns within a file. So we're going to type grep, G-R-E-P. We're going to use a flag for grep, or an option in grep called -c, which this counts the number of a particular pattern. And the number of sequences within a FASTA file is denoted with a greater than sign. So we're going to count the number of greater than signs within the FASTA file. Our FASTA file is going to be denoted by the variable FASTA, and we know that it's a variable because it has a $sign in front of it. And then we're going to put the number of sequences counted with grep into a file called num_sequences.txt. And that's what this greater than sign does here, is it takes the number of greater than signs that are found in the FASTA file and stores them in a file called num_sequences.txt. So we have the script block for our process, but now we have to define the input block. The input block defines the input channels of a process, similar to the arguments in a function in, say, a Python script. A process can only have one input block, which must contain at least one input. The input block is defined using the word input, just like the script block is defined using script, and it uses the following syntax. So within our process count sequences, we're going to hit enter, then we're going to type the word input and a colon, and then the syntax is there is always, and I'm just going to denote this using less than and greater than signs, an input qualifier, and then an input name. And those are how you define your input in the input block. The qualifier defines what type of data is going to be received. So there are a number of qualifiers that I'm just going to type here. We have val, V-A-L, which accesses an input value by name. We have path, P-A-T-H, which handles the input value as a path. We have env, which uses the input value to set an environment variable in the script. We have stdin, standard in, which forwards the input value to the process standard in special file. We have tuple, which I previously mentioned. This handles a group of input values. And then we have each, which executes the process for each element in the input collection. Now, we're not going to go over every single one of these as an example, and our count sequences script that we're writing, or the process that we're making, is going to use path as the qualifier. So if we go back to our input block here, in our input qualifier, we're going to backspace and we're going to type path, and then the input name in this case is going to be FASTA, which is why we have this $sign FASTA here. If this were, say, a FASTQ file instead, or we wanted to name it something else, like let's say we wanted to name it FASTA_files, we would then type $FASTA_files here. But we're just going to keep it as $sign FASTA for simplicity. And so this qualifier tells Nextflow that we have a FASTA file in a path that we are going to give to the script block within this process. And just so you know, the val, path, and tuple qualifiers are the most common qualifiers you are likely to use. So that is how we write our input block. Now the other part of our process that we need to define is the output block. And the output block defines the output channels of a process, similar to the output of a function, like in a Python script. A process can have only one output block, which must contain at least one output. The output block is defined using the word output, just like the input block is defined using the word input, and the script block is defined using the word script. And it uses the following syntax, which is very similar to the input block. So we type output and then a colon, and then we hit enter. And then we have the output qualifier, and we have the output name, just like we did with our input block. Now, when a process is called, each output is returned as a channel. Like the input, the type of output data is defined using qualifiers. And here is the list of qualifiers, which I'm going to type down below, just like I did with the input qualifiers. We have val, which emits the variable with a specified name. We have path, which emits a file produced by the process with a specified name. We have env, which emits the variable defined in the process environment with a specified name. We have std out, or standard out, which emits the standard out of the executed process. We have tuple, which emits multiple values, and eval, which emits the result of a script or command evaluated in the task execution context. So again, val, path, and tuple are the most common qualifiers you are likely to use. We are not going to go over every single example of these qualifiers, and the qualifier for the output we are using is path. So the output block is contained within the process body after the input block and before the script block, as shown here. And we are going to make our output qualifier, like I said, path, and then the output name, which we have to define, is already here for us. It's num sequences .txt, and that is the name of our output. Now we need to do something called emit this output. So to do that, we put comma and then a space, and we type the word emit, and then we type num underscore sequences. And now we can name this whatever we want. We could call it num, we could call it sequences, but for the sake of clarity, I'm just going to give it the same name as the file, which is num sequences. And so just to wrap up what this process we just made does, the output block in this example returns a file called num underscore sequences.txt, which is produced by the code in the script block. The grep command counts the numbers of sequences in the FASTA file by counting the number of greater than signs within the file, and that number is stored in a file called num underscore sequences.txt. Now the emit option, which I just described, is included in the output block, and it allows us to assign an identifier that we can use to reference the channel later. And I'm going to talk more about that in the workflow section. But now that you know how to create a process, I have another challenge for you. This is our second challenge in this section, or this is our second challenge in this episode. I would like you to create a process named count base pairs. So I'm going to go ahead and delete this. So your process is going to be named count underscore base pairs. It's going to take in a FASTA file from a path, and that FASTA file is going to be called FASTA. Within the script block, it is going to run the following command: tail -n +2 $ FASTA file, because the FASTA file is called FASTA, pipe tr -d single quote /n single quote pipe wc -m greater than sign num underscore base num underscore base pairs dot txt. Now, what the heck does this script do? Well, this will actually count the number of base pairs found within a FASTA file. And this is the bash code necessary to do that. It strings together several commands, and then it stores that within a file called numbasepairs.txt. And the output is going to be called num underscore base pairs. So first things first, I want you to answer the questions. What are the qualifiers and names of the input and output of this process? Now go ahead and hit pause here or skip straight to the answer, but try to work through this challenge and see what you can come up with. So the answer to this particular challenge, well, we're making a process called count base pairs. So we need to type the words process, and then we have to define the name of the process. We need to have an open and closed curly bracket. We need to have an input block, an output block, and a script block. And so the input block should be defined with the word input followed by a colon. The output block should be defined with the word output and a colon. And the script block should be defined with the word script and a colon and should be contained within 2 rows of 3 double quotes. The script that it's going to run is here as typed out. So we're going to put that particular line of code here. The input is a FASTA file from a path. So it's going to be path and then the word FASTA. And so the qualifier for the input is path. The name of the input is FASTA. The output is also a path, but this time the name is num underscore base pairs dot txt. And that is the answer to challenge 2. So take a moment to go over this answer, reflect how you did, go back to the lesson material to see if there wasn't something you didn't quite get right. But now we're going to move on to the final part of this episode, which is workflows. So in Nextflow, workflows connect multiple processes and the channels that pass data between them. We define a workflow in a script that ends with .nf using the workflow definition, the word workflow. And the workflow body is contained within curly brackets. So just like a process is defined using the word process and is contained within curly brackets, the same is true for a workflow. So in this section, we're going to go over a 2-step workflow that takes in paired FASTQ files, assembles the reads into genomes using the shovel assembler, and assesses their quality using the QC program Quast. The first 2 blocks of the script are going to be processes, which are called assembly and assembly QC, and the final block is going to be the workflow itself. So we're going to open a new file, and we're not going to run the script at the end. We're not going to run the workflow. I'm just going to show you what the workflow looks like. So let's go ahead and minimize the terminal. We have this untitled document here. So the first process I said was called assembly. So we're going to type that out, process assembly. And a process is defined with an open and closed curly bracket. The input is going to be a tuple. So a tuple contains multiple values, so the qualifier is tuple. We're going to have that tuple contain the sample name as val, sample underscore name, and then we're going to have the other part of a tuple be path, and that path is going to be reads. So that's our input part of the process. We then need to define our output, which again is the word output and a colon. This path is going to contain the assembly files. So the assembly files are going to look as follows. They're going to have the variable sample name, which is also within the tuple. And then their extension is going to be .contigs.fa. So this is how we're telling Nextflow what our output is. And we're going to emit this because we have to pass it to the next process, and we do that by emitting it. So we do comma, emit, and we're going to call this assemblies. So that's our output. So next we need to do the script block, which is the word script followed by colon and 2 lines of 3 double quotes. Now within that, I'm going to give you the command for shovel. If you've used shovel before, this will look familiar. If you've not used shovel, I'll explain it. But first we need to call the assembler shovel, and we do that by typing the word shovel, S-H-O-V-I-L-L. And then we need to give shovel the first read, the forward read, and we need to do -- R1. And since our reads are designated by path and then reads, these are paired, so we need to give it the first in the list reads. So we give a $, an open curly bracket and a closed curly bracket, and then we give it reads and then 0 since it's 0 indexed. And for R2, read 2, we give it another $, open and closed curly brackets, and then reads 1. So this tells Nextflow within reads, read 1 is going to be the first item, and read 2 is going to be the second item. Now the other thing we need to give shovel is an out directory, and that's --outdir, and we're going to call this directory shovel output. And then because shovel needs to be able to overwrite folders, we're going to give it the command --force. Now the last thing we need to do is, once shovel has completed, we need to rename the contigs file with our sample name, because by default, and we're going to talk about this later, actually all the way in the final episode, because we're going to use shovel in the final episode as well. Shovel by default does not give a unique name to the assembly. So if we were to just run shovel over and over, it would just overwrite our assemblies, and we need to keep our assemblies, and we're going to do that by giving them a unique name, which is why in the path here we have the sample name followed by .contigs.fa. So by default, the output of shovel, which is stored in the shovel output directory, is the file contigs.fa. And we're going to move it to $ sample name .contigs.fa, and that will rename the assembly contigs.fa with the sample name contigs.fa. And remember, we can give this sample name in our script because it is here defined as val within this tuple within this input, and it will also similarly be defined in the output and the path. So that is the first process, assembly. We have successfully defined the first process in our workflow. We now need to move on to the second process. Now the second process is the assembly QC using Quast. So we're going to write process again, and then we're going to type in assembly all in caps _QC, and then an open and closed curly bracket. So the input of this process is again a tuple. So we're going to type input colon and then tuple val sample _ name, and then path, and this time the path is called assemblies. Now the output is also going to be a tuple with val sample name, comma, and again a path, but this time the path is going to be named $ curly bracket, not a $4, and it's going to be sample _ name .quast .report.tsv, and that is, TSV, not TSC, and that is going to be the name of our output. So for the script block, we're now going to define what quast is going to do to the assemblies we give it. And if you've not used quast before, the command for quast is a Python script. So it's quast.py, and then you give it the assemblies, which we're going to give here as assemblies. And then it needs an output folder, which it designates with -o, and we're just going to say the current working directory, so we're going to give it a period. And then since quast also does what Shovel does and does not give its report a unique name, we're going to take the output report, which is called report.tsv, and we're going to move it to a unique name. So we're going to do move mv report.tsv, and we're going to move that to $ open and close curly bracket sample underscore name .quast .report.tsv. So this process, assembly QC, in the input has a tuple with val sample name and a path to files called assemblies. It gives as an output a tuple with val sample name and then the path to quast reports. And the quast reports are called sample underscore name quast report.tsv. The script itself is running the Python script quast, so quast.py. We give it the path to the assembly by designating the variable assemblies here. And then we specify an output directory using -o. And then finally, we move the report, which is called report.tsv, to a more unique file name that matches the output sample underscore name .quast.report.tsv. And now we have the two processes of our workflow. So we've successfully defined the processes, and we need to now finally chain them together with a workflow. So after we've defined our processes, we designate a workflow using the word workflow, and then an open and close parenthesis, just like with a process. Now first, as you can see here, Visual Studio Code is very smart and recognized that I was making a script, so it started to color code everything. And that's the benefit of using something like Visual Studio Code while you're coding rather than just a more pared down text editor. So the first thing we have to give our workflow are some reads. And we're going to name the channel of reads, which is the input to our pipeline, reads underscore ch. Very self-explanatory. And it's going to be channel.from file pairs, because this is a paired end data set. And we're going to say that it's the same as the path here, which is outbreak and then fastq data. So we're going to give it the path outbreak / fastq underscore data / asterisk underscore R1 comma R2 close bracket .fastq.gz. Because remember, when we're doing channel.from file pairs, we give it the path and then we give it the two different extensions within curly brackets for the fastq file. So in this case it's R1, and I did a little typo here, it should be R1 and R2, not R1 and R1. So this will tell Nextflow, get every pair of fastq files that end in fastq.gz within this directory, and that is how we define the inputs for our workflow, or rather the inputs since it's not plural. So that's the input channel reads underscore ch, and then we need to give reads to the first process assembly. And to do that, we just simply write the name of the process assembly and then an open and close parenthesis, and we give it reads underscore ch. And that will call that process. And then after that, we type in the name of our next process, assembly underscore qc, and we give it the output of the assembly process, which in this case is assembly.out, because you're specifying the output. And then because our output was emitted as assemblies, we would then use assemblies here to designate that that is the output of assembly that we are giving to assembly QC. And the workflow is as simple as that. You have given it your input, which is paired reads from a particular path. You pass those reads to the assembly process, which assembles them, and then emits them as the name assemblies. And then using assembly.out.assemblies, you pass it to the assembly QC program, which will then perform the QC using Quast. So now I'm actually going to show you a visual representation of this workflow using the same schematic I showed you before, but this time it's going to be labeled with the processes so you can wrap your mind around this using a visual rather than just staring at lines of code. So that's what this looks like here. We have our FASTQ files, read 1 and 2, which we read into a channel called reads_ch using from file pairs. We then pass that to the assembly process, which performs the task of assembling the reads with shovel. We then put that into another channel called the assemblies channel, and that's assembly.out.assemblies, because the assemblies were emitted using the name assemblies within this particular process. And then we pass those to the assembly QC process, which performs the task of assessing the assembly quality with Quast. And let's break down this workflow block one more time just to make sure that everything's clear. This first line here in the workflow creates a channel called reads_ch using channel.from file pairs. And this channel contains paired FASTQ files found in the outbreak FASTQ data directory. This second line here, assembly, calls the assembly process using reads_ch channel as input. The third line calls assembly QC process and uses the output emitted from the assembly process as input. The assembly output is accessed using the .out attribute. And finally, let's do one last challenge. This is our third challenge for this episode. I want you to create a workflow block with the following input and processes. So let me close this. I'm not going to save it, and I'm going to open a new text file. The input is the path to a paired end FASTQ file, data /FASTQs /* open parenthesis R1, comma R2, close parenthesis, close curly brackets, .fastq.gz, and that's going to be the path to the FASTQ files. Process 1 is called trim reads. And it takes the FASTQ files as input, so it takes FASTQ files as input, and it emits output with the name trimmed reads. Process 2 is called read_QC. It takes the output of trim reads and emits an output with the name QC_files. Process 3 is called QC report. It takes in the input of read QC and emits an output called QC report. No, VS Code was being a little too helpful there. It does not need to be capitalized. The output of QC report is going to be stored in a channel named output_ch. So go ahead and take a moment to build that workflow block. You can hit pause here and then I will type out the answer for you guys. So the answer to challenge number 3. So this is a workflow block, which is designated by the word workflow and open and closed curly brackets. We have the reads_ch channel, which is set equal to channel from file pairs, open and closed parenthesis, and the path is data fast queues, and then asterisk underscore R1 and 2 dot fastq dot gz. So that's how we designate our reads as input. The first process is called trim reads. Excuse me, trim with no E. And it takes in the reads channel as input. The second process is read QC, and it takes the output of trim underscore reads, which was emitted as trimmed reads. The next process is called QC underscore report, and that takes in the output of read underscore QC, which was emitted as QC underscore files. And then the final channel is called output underscore CH, which took in the output of QC report, which was emitted as QC underscore report. So I know that was a lot to type, kind of a mouthful to explain, but let me go through it one more time line by line. We have our workflow block. We have the reads channel, which takes in paired fastq files with the R1 and R2.fastq.gz extension using channel.from file pairs. We have a process called trim reads, which takes in the reads within reads underscore ch. We have a process called read QC, which takes in the output of trim reads, which was emitted as trimmed reads. We have our next process, QC report, which takes in read underscore QC's output, which was emitted as QC underscore files. And then we have this final channel here, output underscore CH, which is the output of QC report emitted as QC report. And that is how that workflow block was created, and that is the solution to challenge 3. Now we have reached the end of this episode, and I want to review the key points from this lesson. First things first, Nextflow channels are used to transfer information between processes. There are 2 types of channels that can be used in different ways. Queue channels are able to be used once and can store multiple values, and value channels can be used multiple times but are composed of one value. Nextflow processes are the actions that are executed, and they are made up of a process, function, a name, and a body. And then Nextflow workflows combine processes and channels together to perform a string of actions. And with all of that done, and that brief review of Nextflow complete, we can move on to downloading and running NF Core workflows in the next episode.